In this video, we're back on ratios, but this time we're going to see how ratios can apply to the real world by looking at word problems that use ratios. First, breathe. Do not panic. A word problem is just a problem that applies to real life. We are going to use the UPAC method to remember all of the key steps in solving a word problem, and we're going to apply that to ratios. So read the problem fully and try to understand it before solving. That's the U in understand. Plan. Check the order of the words and check that it matches the numbers in your answer. Read the problem again after solving it to check your answer. So you're going to understand, plan, answer, and check. Follow me as we do those 4 steps to solve each of these word problems. Let's start with this problem. First, let's read it to understand. There are 15 ducks and 12 chickens on a farm. Find the ratio of the number of ducks to the number of chickens. Express the ratio in simplest form. Notice how I used my hands to separate the different quantities that we knew and check that the order, that we're following what the order is. So first I need to think, do I have all the information I need? I need to make a ratio of the number of ducks to the number of chickens. Do I know how many ducks there are? Yes. Do I know how many chickens there are? Yes. And then later I'll make them in simplest form. So now let's plan. Let's put those numbers into a ratio using the correct order. So first goes the ducks, that's 15. Put my colon, and next goes the chickens, that's 12. 15 to 12. Now it's time for me to find my answer by using common factors. Which times table do I see the 15 and the 12 on? To write them in simplest form, I need to divide them by their common factor, which is 3. So 15 divided by 3 gives me 5, and 12 divided by 3 gives me 4. So my ratio is 5 to 4. Now let's check. Can I simplify that ratio anymore? Let's think. Do I find 5 and 4 on the same times table? Nope. Only on the 1 times table. And dividing by 1 will do me no good because it will leave the ratio the same. So I can't simplify this ratio anymore. For every 5 ducks, I have 4 chickens. So the ratio of the number of ducks to the number of chickens is 5 to 4. Keep using those hands to follow that pattern. Let's use the UPAC method again to solve another word problem. First, let's read the problem to understand. That's the U in the UPAC method. There are 40 students in a class. 25 of them are boys. Find the ratio of the number of boys to the number of girls in the class. Express that ratio in simplest form. So I need to find the ratio of the number of boys to the number of girls. Do I know the number of boys? Yes. Do I know the number of girls? Well, not yet. So the first thing I need to do is to find the number of girls. I'm going to use subtraction because I know the total and I know one of the parts, but I don't know the other part. So 40 minus 25, the boys, okay, all the students minus the number of boys should give me the number of girls, which will then be 15. So now I can make a ratio of the number of boys, 25, to the number of girls, 15. 25 to 15. Now, the next step showed me that I needed to put it in simplest form. So I followed my plan. I found the parts that I needed, the missing information from the problem. I've put the ratio in order, 25 to 15. Now it's time to answer by finding common factors to simplify the problem. Well, I noticed 25 and 15 both end in 5, which means that 5 has to be a common factor. Let's divide both sides by 5. So we have 25 boys to 15 girls, and we're going to divide 25 divided by 5 gives me 5. 15 divided by 5 gives me 3. So the new ratio will be 5 to 3. The ratio of the number of boys to the number of girls is 5 to 3. Let's check our answer. For every 5 boys, I should have 3 girls. And 5 to 3 has to be a ratio that we can no longer simplify. Are there any common factors between 5 and 3? Nope. So we must have the right answer. Use that UPAC method, go through all 4 steps to find the answer when solving a word problem with ratios. Let's try an even trickier problem. There are 100 animals on a farm. Animals, that's a total category. There are 32 goats and 28 horses. The rest of the animals are chickens. Find the ratio of the number of goats to the number of horses to the number of chickens. Now notice my hands there. Of course, at the end, we'll express it in simplest form. We are comparing three quantities in this problem. Remember, that's the superpower of ratios. They can go beyond a fraction and not just compare two things, but instead compare three things. All of the things we're comparing are animals, so that's our total. And there's three categories of animals: 32 goats, 28 horses, and the rest are chickens. Because we know a total and we know the parts, we're missing just one part, we can use subtraction to find the missing number. 100 minus 32 minus 28, or you could do 32 plus 28 and subtract that from 100, will give you 40. So that means there are 32 goats and 28 horses and 40 chickens. Notice we're keeping them in the same order. So we've understood the problem and found any missing information that we needed. We kept with our plan to keep the numbers in order. Now it's time to answer the question by finding the greatest common factor of those three numbers and then simplifying. Remember that when we're looking for the greatest common factor of three terms, we start with the smallest term and do the rainbow method to find their factors. So the factors of 28 are 1 and 28, 2 and 14, right? And 4 and 7. Because we went from the outside to the inside, finding all the factors, we know that we have found all the factors through those multiplication problems. So we start from the top. Is 28 a factor of 32 and 40? Nope. That number is way too big. Even if I just multiply it by 2, I'm already over the other two numbers. So let's go down to 14. Is 14 a factor of 32 or 40? Well, no, because 14 times 2 is 28, and if I add another 14, I've also gone over. So 14 doesn't work. Let's go down to 7. Is 7 a factor of 32 or 40? No, it's not. I know 7 is a factor of 35, and that's too close to 32 in order for my times tables to work. So 7 cannot be right. We're going all the way down to 4, and 4 is a factor of 28. It's also a factor of 32, and it's also a factor of 40. So we're going to divide all three terms by 4. When we divide 32 by 4, we get 8, 28 by 4, we get 7, and 40 by 4, we get 10. Remember, we've set this up to be in the correct order with our problem. So the ratio of the number of goats to the number of horses to the number of chickens is 8 to 7 to 10. The order matters. Now that we've simplified, we check to see if there's any more common factors. For example, some of you might have divided these by 2 first, and then you would have had 16, 14, 20, and you should have seen that you could divide by 2 again. So we have to make sure it's in the simplest form before we finish our problem. Now, this is one that I'm going to start you off on, and I'm going to see if you can finish it on your own. In ABC school, there are 24 women teachers and 10 male teachers. What is the ratio of the number of male teachers to the number of female teachers to the total number of teachers? Dun, dun, dun. So I want you guys to count the times we said 2 in that problem, because that gives you a hint about the number of colons you're going to need to write and the number of quantities we're going to be comparing. Our first step is always understanding. So don't jump into the math until you have a good idea of what you're actually trying to solve. So we've been told how many female teachers there are and how many male teachers there are. And we're supposed to compare the number of male teachers to the number of female teachers to the total number of teachers. This is a part-whole ratio. So we need to look for 3 terms. So far, we know the 2 part terms, the number of female teachers and the number of male teachers, but we don't know the whole term yet. So let's use addition to find that whole. We know 2 parts, but we don't know the missing whole, so we need to use addition. 24 plus 10 is 34, so the number of total teachers is 34. Now we need to set them up in the correct order to make the comparison. It asks for the number of male teachers, 10, to the number of female teachers, 24, and finally the total number of teachers, 34. 10 to 24 to 34. Now it's time to find our answer by looking for that greatest common factor. Once again, we're going to start with the smallest number and do the rainbow method. 1 times 10 is 10. 2 times 5 is 10. So we have 10, 5, 2, and 1 as our potential factors. We know 10 is not a factor because everything that has a factor of 10 ends in 0. And 24 and 34 don't end in 0. What about 5? Well, 5 can't be a factor either because all of its multiples have to end in 0 and 5. We know this from divisibility rules. So we need to look at that last option for a factor, 2. We're going to divide each of these numbers by 2 to create a new ratio. So make your next ratio by dividing 10 by 2, 24 by 2, and 34 by 2 in that order. That will give you the ratio of the number of male teachers to the number of female teachers to the total number of teachers. Try that out for me. Thanks for watching. This was a video on how to solve word problems using the UPAC method step by step with ratios. First, we read to understand. Next, we follow the order in our plan. After that, we answer by dividing by the greatest common factor. And finally, we check by looking to see if our ratio is simplified, if it's in the right order, and if it makes sense. Thanks for watching.